Okay, so we're going to look at some functional groups here in advanced nomenclature. And we are going to first, let me just show you the big picture of which functional groups you're going to need to know. It's going to take a little bit of memorization. It's not hard, and the quiz isn't hard, and then you're done with it. I just want you to have a decent exposure to this stuff. So alcohols are indicated by something called a hydroxyl group, which is the OH group that hangs off. And it's a little bit more than a substituent group. These groups, as functional groups, actually change the base name of what we're looking at. An amine, we have a centralized N with 3 possible substituent groups hanging off of it, and we call it blah, 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 something amine. An ether is a carbon chain and then an O and then another carbon chain. When I walked into my high school classroom, my first chemistry classroom, my teacher had on the desk a stuffed bunny rabbit on her desk with like ROR on its back, and we were like, what is that? She's like, you'll find out, and it's the ether bunny. So don't know how ROR connects to the bunny, but it helped me remember. Alkyl halides, we already did this. It's a carbon chain, then you have a halogen coming off of it. So you just name it like another substituent group, chloro, bromo, iodo, fluoro, whatever. Esters. Esters have a combination of something called the carbonyl group and an O in the same, within the chain. So it's a double bonded O and an O within the chain. And there's a really easy way I'll show you how to name esters. Esters and ethers. It's not the ester bunny. It's the ether bunny. Don't get it twisted. Esters are C double bond O-O. When I taught this more legitimately for the actual AP, since it was included on the AP, we had a song for this one, the ester song. No, we're not going to do the ester song. No. Ketones. Now, the carbonyl group is the C double bond O group. If the carbonyl group is within the chain, carbonyl group within the chain, it's a ketone. If it's terminal, where the C double bond O is terminal, oh, now look at that. Look at it freak out. Le freak, c'est chic. Freak out. I didn't come up with that. People at home, that was one of my students. Okay, well, whatever. If it's terminal, it is going to be an aldehyde. So how do we remember this? I remember that if it's within the chain, you see how it kind of looks like one of those really old-fashioned keyholes with the big key that you, in horror movies, the haunted houses had the big, that's what that reminds me of.
Why are the lights off?
I wish y'all at home could hear the humor going on in the class. If it's terminal, we call it an aldehyde because, do you see the ho here? Do you see the ho? See the ho? So, hey Al. Hey Al, see the ho? See the ho? Okay, that is an aldehyde. Amides, you only need to recognize. I'm not going to have you name them. Recognize. You only need to recognize them. Basically, it's kind of a combination of an amine and an ester where you have your double bonded O and your N within the center of a chain. Again, you're not going to have to name those. And then lastly, there's a substituent called the nitro group. It's like any other alkyl group, NO2. All right, so let's move on. Now we're actually going to practice naming with them. What you want to do first, ignore the functional group and name your compound like it's an alkane. Name the long chain. So here, if we have an alcohol, an OH group, our chain is 2. What would that be called without the OH? Ethane. So we're going to drop the E, and we're going to add OL and make ethanol. Okay? I don't need to put a number in this one because indicating where the OH is, because 2 carbons, it's always going to be on carbon 1. But in any other case, like decanol or whatever, you have to tell me 2 decanol, 4 decanol. Tell me where that OH is. Okay? All right, ether. The ether bunny has the centralized little thing there. It ends with the word ether. These are really easy to name. You just name the 2 groups coming on, pretending they're alkyl groups. What was a 2-carbon alkyl group called? Alkyl group is a substituent group. Hanging off, what do we call a 2-carbon group? Forget the di. Just what's a 2-carbon group called? Ethyl. So we have 2 ethyls, so what do we call it, Dwight? Diethyl ether. What if I had a methyl and an ethyl? What would we call it? Not methyl ethyl, ethyl methyl ether. Okay? So those are easy to name because you just take that central O and look at the things hanging off of the sides. Okay? We already know how to name these. We kind of did one yesterday. This is an alkane, just a good old-fashioned ethane. You treat this like any other substituent group. Chloroethane. If it's on a long chain, you have to tell me what carbon it's on. And it goes alphabetically in with methyl and ethyl. It mixes in with all of those. It's no more important than those. This last one, oh, what do you see? Do you see the HO? That's an aldehyde. So when you count your carbons, when you see the HO and you count your carbons, you count the carbon included there. So it's not ethane, drop the E, it's ethanal. Okay? And it's really important for you to name it as an alkane first, then drop the E and add Al. Yeah?
Why don't you count the third carbon?
There is no third carbon. This is just a hydrogen attached. Okay? All right. Ketones are, again, you name your long chain and name it as an alkane. 3-carbon alkane is called propane. Drop the E and add O-N-E. So this is propanone. Any other chain longer than 3, you'd have to give me a number and tell me where that double bond O, that carbonyl group is. You can't have a 1-propanone. Why? You can have a 2-propanone, which is what that is, but you don't need to tell me it's 2 because that's the only propanone. Why isn't that double bond on the first carbon a propanone? Well, it would be something else. Okay, you want to tell me what that other thing would be? The carbonyl group is in a couple things. What are carbonyl groups in?
Oh, it would be a aldehyde.
It would be an aldehyde. A terminal C double bond O is an aldehyde. So that would be propanal if it were on carbon 1. So the only prop that can be a ketone is carbon 2. So there is no such thing as 1-propanone. Does that make sense? Okay. Organic acids, cuckoo. You've got the C double bond O H. It can be written out like that. Most commonly, you're going to see it like this. When I was in school, my teacher drew a box around and went like that and said, "It's a carbox." I don't know why that made me remember it, but you could freaking put a box around anything and call it a carbox, but it works. So, carboxylic acids, when you count these, you again include the C within the carboxylic functional group. So it is, name it as an alkane, ethane, drop the E and add oic acid, ethanoic acid. All right, esters. Oh, my esters have a first name that comes from alcohol. They also have a second name from acids, one and all. Ester compounds smell so nice, flavoring our food precise, even though their names are long, the world without them would be wrong. Oh, the trick to naming esters is to find the acid part. Each carbon has 2 oxygens right there in its heart. That's the whole reason I sang that. Each carbon has 2 oxygens within the central, or in the heart of the compound. So, what you do when you name these, I draw a line separating the 2 oxygens. Now I ask myself, which one of those looks like the more important side? The double bond. That's going to be the surname, the last name. So to name the first name, you just look at what's attached to the single bonded O and name it like a freaking alkyl group, which is what? What's that when it hangs off of something called? Methyl. Then you look at the other side and you count what's there. That alone without the double bond would be ethane. Drop the E and add O8. Methyl ethanoate. Okay? Amines, again, really simple. That nitrogen theoretically has 3 spots that it could take stuff. Sometimes they're all full, sometimes just one is full. There are hydrogen placeholders if there's not something to name. So here we have just one thing coming off of that amine, and that is a group of 2, which would be an ethyl. So it's just ethylamine. What would methyl, ethyl hanging off be called? Methyl, ethyl, and an ethyl. Perfect. Diethylmethylamine. Good. For these, I just want you to recognize the amides. How do I recognize a double bonded O and N? That's an amide. Yay, you got it right. We do need to kind of delve a little bit into aromatics. I just need you to know that either one of these things, which is the same thing, is called a benzene ring. Okay, characterized by alternating double bonds in resonance structures. Okay, its resonance structures are alternating double bonds. So normally we just name one chlorobenzene or fluorobenzene, or we can put a methyl on it and call it methylbenzene, all that kind of stuff. What's a little bit special about benzene, because it's used so largely in organic chemistry, they have special names for when you have 2 groups on there. So if you look at this, if you didn't know this system, you'd say, okay, that's 1 and 2. You'd probably call this 1,2-dichlorobenzene. Does everyone see where that name could come from? Well, because, again, this stuff is so common, the prefix ortho replaces 1 and 2. So we call it orthodichlorobenzene. In the positions 1 and 3, that's a meta, and position 1 and 4, that's a para. So the only thing the orthometa para replaces is that, and it's only replacing it on a benzene ring, not on like a cyclohexane, not on a cyclo anything. It's only benzene specific. Okay? There's a lot of jokes out there that you'll see T-shirts that go like, if you look online, you'll see them. Like, what would that be? Metaphysics. This would be, oh, pelagic. I didn't think about that. That's pretty good. Paralegal. This is one of my favorite. I don't know why. So you'll see stuff like that floating around. That's what that's referring to, the orthometa-para naming system. Okay, let's stay politically correct here, guys. All right. As far as this page, these are some common names I really don't need you to know. What I do want you to know, though, sometimes the benzene ring will act as a functional group. Say, in this case, we have, what would one carbon with an OH off of it be called? Methanol. So that's correct. This is a methanol. These guys are now, that's the main part of this. Those guys are acting as substituent groups now. So there's one of two things you can call these. A benzene as a substituent can be called a phenyl, and I've also heard it called as a benzyl. I really don't care which one you use. This one is the one I learned. That's the most common one. That's probably the most recognizable one. So that would be a diphenyl methanol. See that? Okay. So let's practice naming. Okay, this first one, what kind of family is this first one? Alcohol. So the first thing you want to do, you got to remember that if it changes the base name, it's going to take precedence, and it needs to be on the lowest carbon. So because the OH is here, this has to be carbon 1. That makes, so look at the longest chain. It can go this way, or it could go this way. It doesn't matter. It's 3 carbons. That makes this carbon 2. So first name the alcohol. What? More specific than propanol. Exactly, 1-propanol. And what's on that 1-propanol? On what carbon? So it's 2-methyl, 1-propanol. Does that make sense? Yes, Demo, it makes lots of sense. Good, I'm so happy. All right, 1, 2, 3, 4. No matter what direction you go, you're going to have 4 carbons. So what kind of alcohol is this? More specifically, 1-butanol, not 2. 3,3-dimethyl 1-butanol. Yesterday you couldn't count. Now, I know I didn't teach this to you, but I think, let's see if we can figure it out. The long chain is this. 1, 2, 3, 4. So it's a close. If I didn't know the system, I would say a dibutanol. And I get why you say that, but dibutanol to me, it could be two butes. So the real way to say it is 1,2-butanediol. Isn't that crazy? 1,2-butanediol. I am not going to hold you accountable for that ever again. I just wanted you to see it, okay? So you know it exists. What about this next one? 1, 2, 3. Let's try to name it all at once without breaking it down. Close. I need to know what kind of propanol, because I can have two kinds of propanol. Two methyl, 2-propanol. Because we could have a 1-propanol, guys. We could have 2-methyl 1-propanol, so I need to know it's a 2-propanol. Okay, ooh, what's this one? That's the ether bunny. And what's surrounding the ether? What two alkyl groups? And an ethyl and methyl. So what are we going to name it? Ethyl. Say that 10 times really fast. They're so literal. They're actually saying it 10 times really fast. All right. Everyone at home is laughing at all of you. Yes, they are. Yes. In the last one, would that be a case where you could put it all together as one word? You could. I would, in a case like that, I think what I see more often than not is ethyl, methyl together and then the ether separate. Don't even lose sleep over it. Because every textbook you open will have a different way of doing it. Okay. Next one. Oh, we got another ether. What's on one side? Name it just as a benzene. So benzene is a substituent group here. What do we call it? Phenyl. No, it's a benzene is a substituent group. It's phenyl or benzyl. But we're going to call it phenyl. And what is this group? Ethyl group. So we got a phenyl and an ethyl. What do we call it? What is this ethyl? It's ethyl. Ethyl. Phenyl, ether. Yeah, English is kind of sucky, though. The fact that that's S and that's eth, I understand. But it's ethyl, I promise, and it's ether, I promise. It's not ether. Why is it phenyl? Phenyl is when you see a benzene ring used as a substituent group. It's not the important part of what's going on. All right, this, just for today's lesson, you don't need to know it. You will have to know it next year. This is called an isopropyl functional group. Not functional group, substituent group. It's still 3, so it's still a propyl. If you want to see what because you're going to have to learn this next year, might as well just look. It's 3, so it's still a propyl, but because it's not attached on the end, it's attached 1 from the end, it's an iso group. So it's an isopropyl group. Something you'll learn next year. Don't worry about memorizing it now, but if you know it's an isopropyl and you know that other one is a methyl, what do I call this?
Isopropyl methyl ether.
Ooh, let's try the next one. It's not benzene. That is not a benzene. What is that? Cyclohexane. So how do I make something a substituent group? I drop the E and add YL. So cyclohexyl. Yes, nice. That was good, Dwight. Cyclohexyl. You actually pronounced everything correctly. No. Methyl ether. Okay. Ooh, what's this? Nope. There's no hoe. Where's the hoe? What'd you say? Amine. Amine, not amide. Well, some people actually say amide, but hold on, my phone's ringing, and I'm lecturing. I don't know who that is. We're going to turn off my phone. Thanks. Okay, it's an amine. It's not an amide. If you say amine, that's okay. It's just kind of weird, but okay. So it's an amine, and it's got 2 groups hanging off of them, so it's a Come on, guys. Come on. Diethylamine. Okay, what is this one? Yes. Cyclopentylamine. Muy bueno. The N, just the nitrogen in the middle of it. Okay? Now, an amide, which you only have to recognize, is a nitrogen with a double bonded O. Okay? Now, this was that nitro group, right? This is, don't worry. Ooh, what's that one? How about we name it? Whoa, whoa, whoa. Where are you getting 5? 1, 2, 3, 4. 1, 2, 3, 4. Yes. I just wish people could hear you. Tributylamine. Tributylamine. Good. Ooh, no. Is this one a ketone? No, 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 no. It's not a ketone. No. Ester. It's got 2 oxygens in the heart. So how do we name it? We cut it in the heart. We cut that, and we name the first name as a substituent group with a YL, which would be propyl. Good. Now you count all the carbons. You've got 1 and 2. Ethane, drop the E, add O8. You just have to study it. Ethane, O8. Okay, let's do it again. I'm going to slash it. What's the first name? Good. Not count all the carbons. 1, 2. Ethanoate. But do you see why you get every single one wrong after we say it? That's all that matters. All right, next page. I think this is our last page, guys. Oh, what's this last one? Do you see it? Do you see it? You see the hoe? Okay, what's it called? Aldehyde. So it is, well, the H is understood to be there. Remember, in line structures, it's saturated with H's. So, hold on, I'm answering Will's question. In line structures, we're saturated with H's. Currently, this carbon only has 3 bonds. It's double bonded to the O, and then it's bonded once to the C. It's understood that there's an H anywhere you need a 4th bond. That's what line structures do. So that is already there. Okay? A terminal C double bond O is an aldehyde. So, see the hoe, 1, 2, 3, 4, 5. Yes. No, why don't you need to say 1-pentanal? Good question. It has to be terminal to be an aldehyde. If it's not terminal, then it's a ketone. That reminds me of keytar. You know the keytars, what keytars are? They're from the 80s, and look at the keyboards. So I was at 80s night with a bunch of friends, and 2 of which teach here. Miss Nelson was one of them. And I don't care if I'm telling the story, but, you know, we were having fun singing 80s music and stuff, and we had blow up, and it was Alamo Draft House. It was an 80s sing-along night, and it was, I can't believe I'm telling the story. It's really not that funny, but we were up singing, and then Miss Nelson puts her keytar down on her chair and comes up, and we're dancing, and all of a sudden I see her go, "That beep ran off with my keytar," and she started chasing him through it was the funniest thing I've ever seen in my life. So now when I say ketone, I think keytar, and I think of this whole event in my life. That was really, whew, that was a funny moment. All right. Uh-oh, do you see it? Do you see it? Okay, that's another aldehyde. So guys, that makes that carbon 1. That has to be carbon 1 because the terminal carbon with the carbonyl group in the aldehyde is your carbon 1. So that puts these on carbon 3. So just as a straight up aldehyde, it's a propanal because it's 3. What is on that propanol? Not close. 3,3-dibromo. What do we think about this one? Ooh, someone just said it. Cyclopentanone. Very good. How did you get that? Who said that? Good job. It's a cyclopentane with a double-bonded O. Drop the E at -one. Cyclopentanone. Do I need a number on that? Why? It's a circle. It's the beginning of the circle is always number 1. Now this one, guys, this really doesn't exist. It's a bad example. It's a horrible example. Technically, the C should be on here. But then if that happens, it breaks the octet rule. Carbon has more than 5 bonds. So we're going to pretend this exists and pretend that this carbon is that carbon. Okay? And so in doing that, we have a carboxylic acid group on a cyclopentane. So what would we call it? Yes, cyclopentanoic acid. All right, this one should be easy. I'm not even going to tell you. Close, Mike. You got to tell me where that where that OH is, because we can have 1 pentanol, 2 pentanol. Can I have 4 pentanol? What is it really then? Then it's really 2 pentanol. Good. What's the next one? Cyclopentanol. Do I need a number there? Nope. Because it's a swircle. Oh, what's the next one? A spider. Okay. Yes. Not amide. Dwight had it. And the last one, remember, that's called the nitro group. That's easy. This is your, you could have done this yesterday, knowing what you learned yesterday. It's a nitro substituent group, guys. Single bonds? Okay, where is the nitro? Okay, let's try this again. What's it called? God, that's like pulling teeth. 2-nitroethane. No, not ethane. There's 3 carbons. 2-nitro. Oh, that was supposed to be the easiest one on the page. 2-nitropropane. So, let's holla, last unit of the year.